Group of 80, in a group of 80 elementary children, 48 liked cornflakes, 22 liked both cornflakes and oatmeal, 20 liked neither. And they want the probability to the nearest hundredth. The child selected at random in a group liked only oatmeal. So we have to go, it sounds like a Venn diagram question. There's 80 total, so I'm going to put that on the outside. And then I have cornflakes and oatmeal. All right. See, it's not right. Okay. So how many liked both? 22. How many liked neither? 20. So put that on the outside. So those ones are done. And then 48 liked cornflakes. Well, there's already 22 that like cornflakes. So how many like cornflakes only? 26. How can I find this missing piece? Add them all up and subtract from 80. So 20, 26, and 22 is 68. So how many liked oatmeal only? 12. Now it says here that liked oatmeal only. If this was just if they just said how many liked oatmeal only, you'd say 12, correct? But it says the probability to the nearest hundredth, not 100%, hundredth, so they liked only oatmeal. So it'd be 12 out of 80, which is 1.5. Doesn't say percent, so we just divide them, correct? Call it a day. Difference between if it says probability, you divide by total. If it doesn't say probability, the answer would have been 12, right? Next page. We have a travel agency surveyed 100 people to determine if they cycle or ski. Oh, there's a Venn diagram. Let's draw on it. Okay. So we have cycled, skied, and then who both cycle and ski. So we're going to start there first, which is 17. Then there's 68 who cycle. So how many only cycle? 51. And there's 29 who ski, but there's already 17. So how many only ski? 12. Add them up. We have 51, 63, 80. So how many do neither? 20. So if I said cycle only, you'd say 51. I'd say ski only, you'd say 12. I'd say cycle or ski, you'd say 80. I'd say neither, you'd say 20. Correct? But this one says what is the probability? So we're going to have to divide by the total, 100 total for this one. That a randomly chosen individual of a group of 100 cycles only. So 51 out of 100. Or you could have given the answer 0.51 because I didn't specify either of those are perfectly fine. Dominic and Laura are playing a board game. To move a turn, Dominic must roll either doubles or a sum of 7. So this is one event happening, correct? They're taking the 2 dice and rolling them. If you do 1 dice and then another dice, that's 2 events happening. Take both dice, roll them at once, 1 event. Take 1 card out, what's it, this or this? Then you know it's mutually exclusive or not. When it's 1 event, it has to be 1 event. We'll talk about that tomorrow too. So Dominic and Laura are playing a board game. To move a turn, Dominic must roll either doubles or a sum of 7. So I go and do my 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's 1 event. You roll 2 dice at once, right? And I have the word, bless you, either doubles or a sum of 7. Or means I have to decide if it's mutually exclusive or not, correct? If there's overlap or not. I'm going to list my outcomes first. So I'm going to get 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. How many outcomes are there going to be? 36. 4, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Okay, so with blue, I'm going to choose blue. Then I'm going to do rolls a double. Okay, so blue is going to be rolling doubles. So probability of doubles is how much? How many of them are there? 6 out of 36. My other one, I'm going to do green, is a probability of a sum of 7. I'm doing them in 2 separate colors so you can see if I actually overlap any of them, correct? So sum of 7, 6, 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, 6. Those would add to 7, correct? Do any of mine blue or green? Do any of them blue-green lap over each other? No. So this is mutually exclusive. There's no blue-green overlap. How many of the green are there? Out of 36. When it's mutually exclusive, I can literally just add the 2 probabilities and I'm done, correct? I don't have to subtract overlap because there isn't any. So, the probability of either a double, I'll just go with double by either. Probability of a double or sum of 7 equals 6 out of 36 plus 6 out of 36, which is 12 out of 36, which is 1/3, which is 0.3. If I round it to the nearest hundredth, right? Okay, so mutually exclusive or not mutually exclusive is one event happening. I take out a card. What is the probability it's red or a king? I roll 2 dice at once. What's the probability of a sum of this or this, right? It's one event happening. The last lesson we have to go over is independent and dependent. Independent and dependent. So it's 2 events happening at once. So we're going to flip over. Independent and dependent. So it's 2 events happening. And are they independent or are they dependent? So 2 events happening could be I take out 1 card and I take out another card. So now I have 2 cards, right? First event is taking out a card. Second event is taking out a card. I have 2 events happening. Or it could be I roll a dice and then I roll another dice. Roll a die and roll another die. Or it could be I take out a card and then I spin a spinner. 2 events happening, correct? What we have to decide is are they independent of each other or not? So let's look at independent events first. Independent events are 2 events are independent of the knowledge that one event has occurred, has no effect on the probability of the other event occurring. An example could be I spin a spinner and then I toss a coin. Does spinning the spinner and then tossing the coin affect each other? One event I do alone, another event I do alone. I could do them out of order. I could flip the coin, then spin the spinner, or I could spin the spinner, then flip the coin, and I get the same answer, correct? Because they wouldn't affect each other. Now, what happens if I did this, though? What happens if I took out a card, figure out the probability of it, put back the card, and took out another card? Those would be independent of each other, too, right? I have all 52 cards again, correct? Those are independent. Dependent are events whose outcomes are affected by each other. For example, if 2 cards are drawn from a deck without replacement. So I take out a card and I hold it in my hand. Now I take out another card. This card, the second one, is affected by what the heck I have in my hand over here, isn't it? Because let's say I take out a heart, and I'm holding a heart in my hand. Okay? How many cards do I have now left for the second one? 51 and 1 less heart, correct? So I've knocked this one down. So So this event, the second event, when I don't replace, depends on what I'm holding in my hand on the first. So often, dependent events happen when you do not replace the object. So it's without replacement. So I'm going to give you some examples, and you're going to tell me if they're independent or dependent. Okay? First event is going to be spinning a spinner. Second event is going to be spinning the same spinner. Are they independent or dependent? They're independent. Why? Because I can't take a piece of the spinner off. Right? Say I have a four-piece spinner. I spin it, it lands on green. Great. I spin it again, it can land on anything again. I can't take the piece of the spinner off. Remember, the only time that dependent happens is when you don't replace something. Correct? On a spinner, can I ever take the piece off and spin again? No, I never can. What about coins? What if I flip a coin, and then now I flip another coin? Does the first coin affect my second coin? No, because I can't literally take a piece of the coin off. There's no without replacement. Okay? So, coins will always be independent. Spinners will always be independent. What about dice? Can I take a side of the dice off? No, I can flip the dice or roll the dice. Okay, I got a 6. Then I roll the dice again, I can still get 6, because I can never take that side of the piece off. Correct? So, independent will always be, if you have a coin, it will be independent. If you have a spinner, it will be independent, because I can't take the piece off. If you have dice, they'll be independent. If you have cards, what's the only way they'll be independent? If you put it back, if you replace the card, replace the first card. What about a bag of marbles? How will they be independent? I take out the marble. What do I have to do with it? Put it back before I pull out another marble. So it has to be replace first marble. How it can be tricky, though, is if I have 2 bags of marbles. If I have 2 bags of marbles and I take the one marble out of this bag and I don't replace it, but I'm taking the marble out of the other bag, they're independent because they have 2 separate bags of marbles, right? So 2 bags of marbles would also be independent. Or if I gave you 2 decks of cards and I didn't replace, it wouldn't matter because I take 1 card out of this deck and 1 card out of this deck, right? So they really don't affect each other. So really, dependent only happens when you have one object happening and you can take it and you can hold it and not replace it and then do something else, right? That's the only time it can happen. So if I have a bag of marbles and I take a marble out and I hold it in my hand and now I take another marble out, I have 1 less marble to choose from, right? From the color and from the total. So that would make a difference. Does that make sense between independent and dependent? Okay. We'll look at an independent event question. Bag A, I'm going to write it here. It contains 9 red marbles, 3 green marbles. So that's bag A. Then we have bag B. I'm drawing the bag. Bag B contains 9 black marbles, 6 orange marbles. Now if I take a marble out of each bag, do they depend on each other? No, completely separate events. One's out of this bag, one's out of this bag. I can hold the one out of this bag and just, yay. Doesn't matter because I'm taking this marble completely out of a different bag, correct? So here it says, find the probability, so 2 events are happening, right? Of 1 green marble from bag A, and, do you see how it's an and today? Whereas yesterday it was ors? 1 black marble. So when you have 2 events happening, you're doing this, and then you're doing this. This and this. This and this. 2 events. And what does and make us do in between the probabilities? Multiply. That's it. Right? So, the probability of a green and multiply the probability of a black marble from bag B. What's the probability of a green from bag A? There's 3 out of 12. Times what's the probability of a black? How many are there? And how many black are there? 9 out of 15. Plug it into your calculator. Go. Make sure if you have the old calculators, your fractions are going in brackets. Calculator, the only way your calculator knows that it's a fraction is if you go the alpha y equals enter button and put it in as a fraction, or you put every fraction in as brackets. So type it in. What do we get as a fraction? 3 out of 20, or as a decimal? 0.15. You try example 2. It's out of a class this time. It's like choosing a person out of a class instead of a marble out of a bag, right? This is 2, instead of 2 bags of marbles, we have 2 separate classes of students. Why is this one independent? There's 2 classes. You're choosing one kid from one class, one kid from another class. It's not affected, right, by each other. What if I chose 2 kids from the same class? Then what would it be? If I chose 2 kids from the same class, what would it be? Dependent, because I can't replace the kid and pick them again, unless it was like for prizes or something like that. So 2 seniors, 1 from each government class. Each government class, that's what makes it independent, just like marbles out of 2 separate bags, correct? Are randomly selected to travel to Washington, D.C. Wes is in a class of 18 students. Maureen is in a class of 20 students. Find the probability that both Wes, so probability of, I don't know why I'm writing it, the whole word, probability of Wes and multiplying the probability of Maureen will be selected. How many Wes's are there? Out of? And how many Maureens? Out of 20. When I multiply these, what do I get? 1 out of? And what does that reduce to? Or sorry, what is the decimal?
0.0027.
So it's a small probability, which it should be, right? It's tiny. You have to pick 1 out of each of them. But first off, they have to both get picked at the same time, out of class of 18 and out of class of 20. So it should be a small probability. Okay, we're going to flip over. Probability with dependent events. Remember that independent events have no influence on one another. You could do them out of order. You could have picked Maureen first, then Wes, and I'd still get the same answer, correct? Because they aren't affected on each other. That's how you can tell if something for sure is independent, is if the 2 events can be actually done in opposite orders and you get the same answer, right? Dependent events do have influence or effect on the other events, the dependent ones. Independent events, tossing a coin, rolling a die, spinning a spinner. Events with replacement, the sample space remains the same. So that means that your total stays the same, because if you take it out, you put it back. Take it out, you have the same total, right? Dependent events, events without replacement, the sample space will change, your total will change. So instead of having 52 cards, if I hold one, I'm now going to have 51 cards. It's going to change the whole total. Picking a card and keeping it before picking out another card, one that would affect your second pick. Conditional probability, the probability of an event occurring given that another event has happened. So this is what's going to happen to be dependent events. You'll see it on your formula sheet. This one's the independent one where you just multiply the 2 probabilities. The dependent one, it looks weird. It goes P of A and B equals P of A times P of B slash A. What the heck does that mean? That just means probability of A, probability of B given that I'm holding A in my hand. That's all that means, right? Probability of B given that A happened. A occurred, I'm holding that card here. So there's no like operation in there. It just means you have less cards to choose from. That's all that B slash A means. It looks way more confusing than it is, and I rarely even use those formulas because I just know that if it's a dependent event, I'm going to have this out of 52, let's say, and now it's going to be out of 51. That's all that means, right? No extra math happening. So let's look at a dependent event. A card is pulled from a pile that consists of 5 black, 6 purple, 8 yellow, and 1 green. Now they'll do this rather than give you a deck of cards because now you're all at the same fair game here. It's a brand new deck of cards no one's ever seen before, right? Then, without replacing the card, another one is pulled. So without replacing it. So what's the probability of getting a yellow, then B, then a black? So we could say this would be probability of yellow, and then, if you want to think about it that way, and then a black. It's 2 events happening. When 2 events are happening, I'm doing a yellow and then a black. I'm going to multiply. When 1 event is happening, it's going to be yellow or black, which can't happen. It's weird. Okay. So yellow and then black. So how many yellows are there? 8 out of how many total cards? Add them up. 20. So that's the probability of yellow. And what's the probability of black? 5 out of 19. It goes down by 1 because I'm holding the yellow card in my hand. It's right here, right? Yeah, hard people. Okay, so 8 divided by 20 times 5 divided by 19. Make sure you're all typing in your calculator practice. See if you're getting it same as me. And I get 2 out of 19. Which equals 0.11 rounded. You're going to do 2 to 7. So independent and dependent happens when you have numerous events happening. I'm taking out a card and then a card and then a card. That would still be independent and dependent. The fact that we're not replacing the card means it depends on the previous one. So try that one out. So we want P and then P. Well, how many P's are there? 6 out of 20. And then what's it going to be? 5 out of 19 because the purple is going to go down as well. So how many is this going to be? Sorry, 3 out of 38?
Yeah.
Which is 0 decimal. 0.78. Okay. It can't be 0.7, but you must have said 0 and I missed it. Okay, G and then B. G is green, 1 out of 20. B is black, 5 out of 19. What does that reduce to? 1 over 76, which is? Okay, G then G. So we have a green, 1 out of 20. And then another green. 0 out of 9. Wait a second. This is going to be 0. Does that make sense?
No.
Yes. What's the probability of grabbing out a green and then another green if I only have 1? Ain't going to happen. 0. So the only way that you could actually get a probability of green and then green is if I told you I did what in between?
You put it back.
You put it back. Yep. Then this one's black. So there are 5 out of 20. Then yellow, 8 out of 19. And then green, 1 out of 18. So what do we get? 1 over 171? Which is?
0.005.
Okay. Then we have purple, purple, purple. So there are 6 out of 20, and then 5 out of 19, and then 4 out of 18. So what do we get? 1 out of 57, which is?
0.0175.
Okay, we have a green, purple, yellow. Green, 1 out of 20. Purple, How many purples are there? 6? 6 out of 19. And then yellows? 8 out of 18. And what does that turn out to be?
2 over 285.
4.
0.007.
Okay.
Is it okay if we round into the
Decimal?
yeah?
Absolutely. On a test, I would have to ask you like nearest hundredths or something like that. Sometimes you have to say to the nearest hundredth percent or something because the decimals are so tiny. So they'll say percent so that they can actually give a number. Because if you round like 0.003, it would be 0, which makes no sense. All right. Next page. All right. Here we have a box of marbles. We have one box. It contains 5 purple marbles, 3 green marbles, 2 orange marbles. 2 consecutive marbles are drawn without replacement, which immediately makes it be dependent, correct? The 2 events depend on each other, whatever the heck I'm holding in my hand. Okay? I want you to try these ones. Find the probability of orange, then green. Both marbles are purple, so purple, then purple. Purple, then anything but purple. And then I want you to try this one, example 5. So 4 and 5, try them out, please. So this one says a box contains 5 purple marbles, 3 green marbles, 2 orange marbles. We're not replacing. So how many is that in total? 10, right? How many oranges are there? 2 out of 10. And then I pick another marble. I don't take a marble or a marble, right? That would mean like I don't have 2 if I or it, correct? But when I have 2 marbles or 2 events, I have to do this event and then this event, correct? And multiply. Green is how many? 3 out of 9. When I reduce that, I get? Which gets me?
0.067.
Both marbles are purple. So it would be 5 out of 10 times 4 out of 9. So we really have to look for the with replacement or without. Because if it was out with replacement, it would be 5 out of 10 times 5 out of 10. Right? So that's really the word we're looking for when we see these. So what does this reduce to?
209.
Which is?
0.088.
The first marble is purple. So there's 5 out of 10. And then the next one is anything but purple. So 5 out of 9, which reduces to?
5 over 18.
Which is?
0.278.
All right. Example 5. You can stand a deck of 52 cards. We're pulling it out of one deck of cards. Make sure you're turned around paying attention. So we have a deck of 52 cards. And here it says without replacement. So dependent or independent? Do the cards depend on each other? Yeah. Dependent. So we're taking a king out first and then a jack. And multiply. How many kings are there? 4 out of 52. And a jack? 4 out of 51. What does that reduce to?
4 over 663.
Which is?
0.006.
So these are the ones that often, if they put them into decimal form, they're going to ask you to get it to like the nearest percent or the nearest tenth of a percent, because we're going to have to times it by 100 to get some sort of decimal even, right? Like if this is to the nearest hundredth, I would actually get 0.01 because this is bigger. But most often they'll turn it to a percent or they leave it as a fraction. Face card. How many face cards? 12 out of 52. Aces? 4 out of 51. So we get? Nope, 12. Jack, Queen, King, 4 suits.
Oh, yeah.
You get math. True, true. What do we get as a fraction?
4 over
4 over 221? And what is that? 0 decimal?
0.2.
0.2? Okay. 2 aces. How many aces are there? 4 out of 52. Now I'm holding an ace. So now how many do I have left? 3 out of 51, which gets me what? Pardon? 1 over 221, which is 4, 5. Okay. Okay, next page. Okay, we're going to deal with these ones tomorrow because they're the harder ones. But what I'm going to get you to do is scroll ahead. Oh, my arms. No, my arm's being weird. I must have laid on it weird. Okay, example 13, please. Flip ahead to example 13. Okay, example 13. We're all looking at example 13, so make sure you're on example 13. Yeah. Okay. So which of the following is not an example of independent events? Independent events have to happen when you have two events happening because it's events. So 2 or more events. Independent means I could find the probabilities out of order and I would get the same answer, correct? Independent means the second one doesn't depend on whatever the heck the first one was. Okay? So rolling a die and spinning a spinner. Does rolling the die affect how the spinner is spun?
No.
No. So that one's independent, so we're not going to circle it. Tossing a coin 2 times. So I flip a coin, I get a head on the coin. Let's pretend. Then I flip a coin again. Does it affect me that I flipped it? No, because I can't take a piece off that. I can't hold it. I can't... But you can't. Okay. C. Picking 2 cards from a deck with replacement of the first card. Does the second one depend on the first if I replaced it? Nope. So this one's independent. Selecting 2 marbles one at a time without replacement. Without replacing it means it depends. So it's a dependent event. So multiple choice, it says as an example of, not an example of an independent event. So it would be D, because this one is dependent. Here it says a club has 25 members. 20 boys, 5 girls. 2 members are selected at random to serve as president and vice president. Oh, I gave them what? I gave them roles. I gave them jobs. This is a what? A permutation, and it's going to be a probability because it says, what is the probability that both will be girls? So I need both girls. How can I guarantee getting both girls? Choosing them from the girls, correct? So I know it's going to be 5 and 2, but what letter am I going to put in between? P. Why? Yeah, because we gave them roles. Now the great thing is, if the top is a permutation, the bottom has to be one as well. Now remember, the bottom is total no restrictions. So what's my total? 25. P. 2. If I pick 2 for the top, I have to pick 2 for the bottom, right? So type that in. See what you get. Everyone's practicing it. Everyone's practicing. Except for the people on their phones. They're not practicing it. Except for one person who has a calculator on their phone. Which is not you. Okay. Now you, Ed. Stop holding the phone in your hand. It's called an addiction. First step is admittance. Actually, denial. You're there. Second step is admittance. Okay. Which answer is it? It's C. Okay. Maria rolls a pair of dice. Watch me. Maria, I just rolled the dice. How many events happened? I'll come back. One event's happening. So when it's one event happening, it's either mutually exclusive or not mutually exclusive. How is there another giveaway? Well, let's read more. Maria rolls a pair of dice. What is the probability she obtains a sum that is either a multiple of 3 or a multiple of 4? So or means mutually exclusive or not. Now I'm rolling 2 dice. 2 dice, and both of these questions are about sums. So I'm going to do the sum array. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Really teeny tiny. And because they're both sums, I'm not actually going to list the outcomes. I'm just going to list what they would sum to in a different color. So this one would sum to 2. This one would sum to 3. 3 and 1 is 4. 4 and 1 is 5. 5 and 1 is 6. 6 and 1 is 7. They just go up by ones. 2 and 1 is 3. 2 and 2 is 4. 5, 6, 7, 8. 3 and 1 is 4. 3 and 2 is 5. 6, 7, 8, 9. 4 and 1 is 5. 4 and 2 is 6, 7, 8, 9, 10. 5 and 1 is 6. 5 and 2 is 7, 8, 9, 10, 11. 6 and 1 is 7, 8, 9, 10, 11. And you should always end with 12 because it's 6 and 6. Correct? Okay. What is a multiple of 3? Starts at the number, goes up by the number, right? So the first one would be 3, then 6, then 9, then 12. So I'm going to circle those in red. The sums of multiples of 3. 3, 6, 9, and 12. Okay, what's the probability of a multiple of 3? 3 sum. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Out of how many? 36. Then I have to do the next ones, which is the probability of a multiple of 4 sum. We're going to do those ones in black. So multiples of 4 start at and go up by. So 4 would be the first one. No overlap has occurred, correct? Then 8. No overlap has occurred. Then 12. Ooh, what happened here? 12 overlapped, didn't it? I have 1 that overlaps, don't I? So is this mutually exclusive or not mutually exclusive? Not mutually exclusive. What's the probability of a sum of 4? 1, 2, multiple of 4, sorry. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I add those, but what do I have to make sure I do? Subtract off the overlap. How many overlapped? 1. So it's actually going to be 20 out of 36. Which reduces to 5 out of 9. Make sense? We'll go back one. Because I skipped a question. We are. Rebel without a cause. No, it was asked. One marble is randomly drawn, then replaced. Oh, I replaced it. What are these events? What are these events? Independent. From a jar of 2 white marbles and 1 black marble. It's a crazy amount of marbles. There's 3. A second marble is drawn. What is the probability drawing a white then a black? So what's the probability of a white and then the probability of a black marble? How many whites are there? 2 out of? How many marbles? 3. And then a black? 1 out of how many marbles left? How many marbles left? 3, because I replaced it. They're all back. So it's 2 out of 9. We have one little thing to learn tomorrow, and then we're going to start reviewing. Because your test is on Wednesday. Thursday is a day off. So no.